a region fuel a nation, yet its people still struggle to live well. This is the reality of Jharia, a place rich in energy resources but still facing everyday challenges in living standards, infrastructure, and environmental conditions. We are Team Energy Volt and we see this not just as a problem but as an opportunity. And today, through this platform, we aim to present a practical and sustainable solution, one that balances energy need with better living conditions for the community. Our focus is a 77.8-acre site in Jharia, Jharkhand, located in rural Jharkhand. This area operates under a tropical, wet and dry climate. While the land is accurately underutilized, it sits at the heart of India's energy production hub, yet remains ironically energy poor. We have strong advantage in large and land availability and skilled a mining workforce, but face challenges like poor air quality and ground instability. This creates a great opportunity to build a fully energy independent township using an integrated renewable energy. There are several facilities like markets, restaurants nearby, but there is a lack of schools and hospitals in the vicinity. So we have decided to build them within the community itself. So why Jharia? Jharia fuels the nation, yet its own people live in darkness. Those who produce the nation's energy should not have to live with the highest pollution and the lowest reliability. Our purpose is to bridge this gap for 2,000 households. Our on-site study revealed critical hazards. Mine dump sits dangerously close to homes. Coal dust levels are at crisis levels on every surface. There is no formal sewage system and power lines are exposed, aging and poorly maintained. Most residents still rely on coal stove, which exacerbate both indoor and outdoor pollutions. To design a fair system, we have analyzed three personas. Our EWS group earns less than 3 lakh per annum, while LIG earns between 3 to 6 LPA. They struggle with rising LPG and electricity costs. Our mid-income group, often mining technicians or engineers, face the sinking asset anxiety where underground fire make their home unsellable. And finally, the HIG earn above 18 lakh per annum. Here we have segregated the problem in short and long-term issues. Now let's talk about major problems. Our first problem is coal dependence. Jharkhand's energy mix is 97.8% coal thermal. While coal provides a stable baseload, it emits 35 billion tons of CO2 annually in this region alone. We need gradual resilient shift towards renewable. And our other problem is reliability. The reliability gap is staggering. During the peak cut season from April to June, residents face 12 to 14 hours of power cuts daily, sometimes exceeding 18 hours during extreme events. We are purchasing electricity while living on the top of world's largest coal reserve. And our other concern is energy loss from fires. The Jharia coalfield fires have burned over a century, wasting 10 terawatt hour of energy every year. That is enough to power 3.5 million homes. Our approach is radical. We cannot stop the fire, but we can recover energy from it while providing architectural solution to shield residents from toxic gases. Moving on to energy demand, here we have surveyed several households and found the average uses per appliance. Then calculated the total demand for all the different groups LIG, MIG and HIG. The load profile we have calculated demand based on seasonal uses. In summer, a single HIG home peaks a 14.97 kilowatt hour a day due to a 1.5 ton AC units. Our total community needs, including essential services like the school, hospital and water treatment, is 6.463 gigawatt hour per year. Let's see our solution. We rejected hydropower and wind due to site unsuitability. Our proposed new energy basket is three-pillar system: geothermal, solar and biogas. Geothermal provides our 24/7 base load, solar provides bulk low-cost generation, and biogas solves our waste and cooking fuel crisis. Our geothermal solution is site-specific. We have chosen a location 3 km from our site in Bhaura mines. Since Jharia lacks natural underground fluids, we will use a coaxial wellbore system. By drilling a 3050-foot closed-loop pipe, we will circulate fluid to harvest heat directly from the underground fire zones. This provides a 2.25 gigawatt-hour annual supply with 100% reliability and no seasonal fluctuation. For solar, we utilize a tiered approach: panel line 0.65 megawatt using Vary panels, floating solar 1.16 megawatt on local pits and lake using dual glass bifacial panel, rooftop 14.1 megawatt capacity on community building using luminous mono half-cut solar panels. In Jharia, bifacial topcon models are essential. They capture reflecting light from coal ash boosting yield by 10 to 15%, and their dual glass design withstand the frequent scrubbing needed to remove sticky coal soot. To manage solar variability, we are integrated a 5 MW BESS with 10 MWh of storage capacity. This system provides monsoon smoothing and evening peak support, ensuring the community never experience the blackout again.
Our next solution, biogas. In Jharia, coal chulas cause pollution up to 5 to 10 times the safe limit, along with high costs and health risk. We propose a 15 TPD biogas plant generating 1500 meters square daily, enough for 8,000 residents. It's cheaper than LPG and locally produced. Our next solution will involve solving reliability issues. To ensure reliability, we use underground cabling, a central distribution center, smart meter, and grid forming inverters. Together, solar, geothermal, and biogas power a centralized grid that means demand, stores excess, and supplies surplus back to the grid.
We shall now begin with our next part of our presentation. Starting with the community plan, we have divided the community into three segments. One is the HIG with 3 BHKs, one is the MIG blocks with 2 BHKs, one is the 1 BHK LIG blocks for lower income groups, and again then we have the EWS category for the lowest income bracket. Our mission is to redefine living in Jharia through cleaner environments, safer spaces, and dependable infrastructure. The entire site has been designed in a way keeping in mind the existing flora and fauna. We have designed and developed the landscape in a way to conserve the existing water bodies and also develop bioswales so that it reduces the existing ambient pollution and also decreases the overall temperature. Coming to our floor plans. First up, we have the EWS units for the marginalized and displaced communities of Jharia. Then we have the 1 BHK units for the lower income group and the 2 BHK units for the middle income groups. Our design has focused on providing all the amenities and areas at a very small building footprint. The 3 BHK units spread over 160 square meters of space has 3 bedrooms, a large living and dining room, and 2 terraces. All the units have been designed keeping in mind the site context. All units are 3-side open to enhance the living conditions and the social welfare and well-being of the people residing in them. Keeping in mind the lack of basic infrastructure across Jharia, we have decided to provide a school, a hospital, cheap electricity in-house production, rainwater harvesting, an on-site sewage treatment plant, biogas plant, and also green walling and dust suppression technology, keeping in mind the adjacent coal fields and dust that comes to the site. In addition to these amazing facilities, we will also develop a cricket field, playgrounds, community gathering areas, and a shopping complex for the benefit of the residents. Engineering and material design solutions. Our main goal is to utilize coal overburden and convert this hazardous waste into high performance building materials. Coal overburden can be utilized to build eco bricks or masonry blocks, manufactured sand in geopolymer concrete, or as a road sub-base material and embankments. It helps us clear out the hazardous waste and provide a green alternative to traditional construction materials. Hence, reusing coal overburden gives us numerous benefits by repurposing the waste to be utilized in material constructions. They have lower embodied energy, higher thermal mass, and rank high on sustainability. Coal overburden can be used in masonry blocks. They provide a savings of approx 30 to 40% and provide a high thermal insulation and dimensional stability. Or they can also be used as manufactured sand in place of natural river sand, providing a savings of 75%. It is a very good material. They can also used in geopolymer concrete as a binder or as lightweight expanded aggregates. This reduces the dead load weight of a building. LECA materials are used as filler materials. They provide 30 to 40% weight reductions and helps in areas with high seismic activity. Overburden can also be used as pavement or sub-base materials during road construction or in interior roofing and flooring materials. Stoneware tiles and ceramic composites can be made with overburden. Keeping in mind the hot and humid climate of India, we have utilized passive cooling strategies such as Persian wind catchers, XPS polystyrene phone boards, and double glazed glass windows. These reduce the ambient temperature by 5 to 10 degrees without utilizing any electricity. We have also provided green walling for dust suppression by utilizing local species of trees such as teak, ashoka, mango, peepal, and arjun. They are heavy lifters that absorb the burnt of coal dust and chemical load that might come to the site from the nearby coal mines. Our goal is to utilize rainwater harvesting to the fullest extent. All the water that we save reduces our requirement for external water, and also this water can be utilized for the site specific services such as cleaning or watering the plants. We have provided the water supply layout plan, how the water is distributed all across the site, then the sewage lines layout plan and the electricity lines layout plan to exactly show how electricity is coming to the site and is being carried over to all the houses in the site. Rendered images and building features. The breathing building envelope. Jharia has high levels of suspended particulate matter. Our buildings would act as a filter between the industrial exterior and the living interior. Double skin facade and dust repellent surfaces has been developed for this exact issue. Coming to the community thermal heavens. We have provided cooling towers, terrace gardens and bioswales. We have preserved the existing site water bodies to increase the living conditions and provide better air quality. Coming to building specific interventions, mining regions can sometimes experience minor ground tremors. Hence, lightweight partitioning made of leca and interlocking masonry with COB blocks helps us provide better structural integrity. Also, we have used the solar panels to make shaded terraces and plantation areas, which reduces the dust on our site.
Let's look at the cost analysis for construction. We have achieved a lean construction cost of Rs 1666 per square meter. Even with a 5% uncertainty buffer, our final incurred cost is competitive Rs 1750 per square meter. Our 4-year roadmap includes 3-month assessment, 6-month initiation with permits and tenant rehabs, and a 2.5-year construction phase prioritizing EWS housing first, followed by LIG, MIG, and HIG. This is the heart of our project. While we utilize the PMAU 2.0 interest subsidy for LIG and MIG families, we are taking a truly holistic and humanitarian approach for the most vulnerable. Our structure allows for 300 EWS units to provided at zero selling price. EWS people are those that are displaced by mining activities or subsidies. By eliminating the debt burden for these families in Jharia, we bridge a disposable income gap of nearly 25,000 compared to surrounding communities. While surrounding area face 5 to 7 hours of daily power cuts, our community will have zero outage through integrated backup system. We cut carbon emissions by over 90%, eliminate diesel generators and reduce indoor PM 2.5 by 95% by switching from coal to biogas, bringing air quality close to the WHO safe limits. Our reliability stems from a hybrid energy system. We use solar for peak summer loads, geothermal as a stable weather independent base load, and a biogas as a year backup and cooking fuel. This triple redundancy ensures a clean, continuous and local sourced energy supply. Financially, the project is robust. Our utility capex is Rs 116 crore, covering a 47.5 crore solar plant, a 20 crore STP, and our geothermal and biogas facilities. The construction of 2050 houses unit represent a 364 crore investment. We have also factored in essential community infrastructure, including a 17.9 crore school and a 17 crore hospital. Our diversified revenue model generates 13.35 crore from electricity, 12.2 crore from the school, and 9.6 crore from the hospital annually. With a 3% interest rate, the project breaks even by 2041 and repays its own loan within 11 years, demonstrating both social impact and financial viability.